1, the topic is all about the measures of central tendency. It's about finding the average or typical value in a set of data. It helps us understand the overall pattern of information by showing where most of the numbers are centered. That this topic includes three main types, which is mean, median, and mode, which represent the average, the middle value, and the most frequent value in the data.
The median. When we say the median, it is the middle point when values are arranged in numerical order, denoted by MD. In calculation, we have their odd n and even n. So the numbers of odd are 1, 3, 5, 7, 9. And for odd, we have the numbers of odd are 2, 4, 6, 8, 10. However, as you can see, beside the odd and even, there has a letter N. So letter N stands for the number in that position. So let's proceed for our example. We have two examples there, which is odd and even. First, we're going to focus on odd. So the formula of odd is MD equals x open parenthesis n plus 1 close parenthesis divided by 2. Now in the data we have there 10, 11, 11, 13, and 15. To identify the n, which is the number in that position, the 10 is equivalent of x1, 11 is equivalent of x2, and another equivalent of x3 is 11, and 13 is x4, and x5 is 15. So next is copy the formula and change the letter n into 5 since our x5 is 15. And remember, we're focusing on odd. So next is add the 5 plus 1, which is 6. And 6 divided by 2 is 3. And copy the x3. So in the data, our x3 there is 11, and that is our median in that problem. So the example of even is, we have here the data, which is the 75, 82, 87, 88, 90, and 94. To find the n, we have x1, 75, x2, 82, x3, 87, x4, 88, x5 is 90, and x6 is 94. So 94 is our x6, which is our n. So the formula of n is MD x n divided by 2 plus x open parenthesis n divided by 2 close parenthesis plus 1 divided by 2. So in the formula, you're going to change the both n into 6 and copy the both divided by 2. So MD equals x 6 divided by 2 plus x open parenthesis 6 divided by 2 and close parenthesis. So the answer of this is x3 plus open parenthesis x3 close parenthesis plus 1. So x3 plus 1 is x4. So copy the x3. We have x3 plus x4. So the equivalent of x3 is 88 and x4 is 87. So next we're going to add the 87 plus 88. So 88 plus 87 is 175. Next is we're going to divide. So 175 divided by 2 is 87.5, and that is our median in the problem.
In this slide, we will talk about the mean. What is the mean? The mean is the average quotation average of the given set of numbers. Like in this slide, you're given 5 numbers. First, you need to add all that numbers and have their total. Then divide the total depending on how many numbers that you are given. Like in this slide, we have 5 numbers. So the total divided by 5, that would be the mean. In this slide, we will talk about the mode. The mode is the commonly appearing number in a given set of data. Like for this presentation or for this slide, we have 5 numbers. Then 11 appears the most in a given set. That's why the mode in this given set of data is number 11.
Let's have the skewness of distribution. We have here 3 parts of these, which are the first one, symmetrical distribution. It has the mean, median, and mode have the same value, or we have here the bell-shaped curve. Next is we have positively skewed. So we have here the tail points right. It says here that mean is larger than median and median is larger than mode. So mean is the largest, pulled by high scores. And the last one, we have negatively skewed. Okay, we have here tail points left. So we have here the mode as the largest, median is larger than mean. So mode is the largest, mean pulled by low scores. This time, we have the normal distribution or the bell curve. We have here the definition, a symmetrical probability distribution where data near the mean are more frequent. Okay, we have here appears as a bell curve. That's why it's called bell curve. So we have here the key properties which are symmetrical about the mean. So we have here mean is equals to 0. So standard deviation is equals to 1. So we have here 0 skew and kurtosis of 3. Now, let's have the modality and kurtosis. So what is modality and kurtosis? Okay, now let's start with modality. So modality refers to the number of peaks in a data distribution. Okay, once more, a mode is the value that appears most frequently in a data set. So we have here 4 types of modality. First is the unimodal, so the distribution has 1 peak. Next is bimodal, it has 2 peaks. Third is a multimodal, so it has more than 2 peaks. And the last one is uniform distribution, so this is no clear peak. So next is the kurtosis. So kurtosis measures how peak or flat a distribution is compared to a normal bell-shaped distribution. So it tells us about the tailed nest, how much data is in the tails versus the center. So we have here 3 types of kurtosis. Let's start with mesocortic or the normal. So this is the standard bell curve, moderate, tails, and peak. Next is leptokurtic. So the curve is tall and thin, high peak, heavy tails. So we have here the data have more extreme values. Okay, and the last one we have platycortic. So the curve is flat and broad, low peak, light tails. Okay, data are more evenly spread out. Okay, so that is the kurtosis and modality. So I think that would be all for our presentation. Thank you so much for listening and see you next time.